Welcome to another episode of Mastering Cybersecurity, developed by baremetalcyber.com. Let's dive in. Cross-site scripting is often misunderstood as an attack against a web server, but the most important effect occurs in the browser of another user. The vulnerable application accepts or processes untrusted content and then places that content into a page in a way the browser treats as executable script rather than ordinary data. That distinction changes both the risk and the defense because the attacker is abusing the trust relationship between the browser and the affected website. A defender therefore needs to answer a practical question. Where can user-controlled data cross the boundary from harmless content into active browser instructions? By the end of this episode, you should be able to explain how that transition happens, what the script can do in the victim's context, why several common defenses are incomplete, and how secure output handling prevents the browser from giving data the power of code.
Cross-site scripting, XSS, is a web application weakness that allows untrusted script content to execute within a page viewed by another user. The application does not necessarily intend to run the content. It fails to keep data separate from executable instructions when building or changing the page. The browser then processes the malicious content as though it came from the trusted site, which may give the script access to page information, browser-visible session data, and actions available to the signed-in user. The central distinction is simple. The attacker supplies data, the application places it into an unsafe output location, and the browser interprets it as code. People often focus only on suspicious input, but XSS is fundamentally an output handling problem. Input controls can help, yet the decisive question is whether the application safely represents untrusted content in the exact context where it appears.
The browser's trust model explains why XSS can be so damaging. Browsers separate websites through the same origin policy, which normally prevents one origin from freely reading or controlling another origin. When malicious script is inserted into a vulnerable page, however, the browser may treat that script as part of the affected site's own origin. The script is no longer approaching the site from the outside in the way an unrelated website would. It is running inside a page the browser already associates with the trusted application. That position may allow it to read information displayed on the page, change visible content, submit requests that the user is authorized to make, or interact with browser storage that the page can access. The same origin policy has not failed. The application has caused the browser to apply that policy to content that should never have been trusted as executable code. XSS appears in several forms, and the difference concerns where the untrusted content is stored and how it reaches the browser. Reflected XSS occurs when an application takes data from a request and immediately returns it in a response without safe handling. Stored XSS occurs when the application saves the malicious content and later delivers it to one or many users, which can make the exposure persistent. Document Object Model, DOM-based XSS, occurs when browser-side code takes untrusted data and places it into a dangerous location while modifying the page. These categories describe different data paths, but they share the same underlying failure. Data reaches a browser context where it is treated as active content. Classifying the form helps defenders locate the responsible code path, determine how many users may be affected, and decide whether the dangerous content must also be removed from stored application data. The phrase malicious script can make XSS sound limited to stealing a session cookie, but the possible effects are broader. A script running in the victim's context may alter the page, display false instructions, change where a link leads, redirect the browser, capture information entered into the page, or make requests using the victim's active session. It may also read data that the current page can access and send that information elsewhere, subject to browser controls and the application's configuration. Some session cookies use the HTTP-only attribute, which prevents ordinary page script from reading their value directly. That protection is important, but it does not make XSS harmless. A script may still perform actions through the authenticated page, manipulate what the user sees, or obtain other accessible information. The practical consequence depends on what the affected page can display, change, approve, or submit for that particular user. Unsafe output is not one single coding mistake, because web pages contain several distinct contexts. Untrusted text placed into ordinary page content needs different protection from untrusted data placed inside an attribute, a web address, a style value, or a script block. A representation that is safe in one context may remain dangerous in another. This is why output encoding must be context appropriate rather than applied as a generic cleanup step. The application should convert special characters into a form the browser will display as data instead of interpreting as markup or code. When rich content is genuinely required, careful sanitization may be necessary to allow a limited set of safe elements while removing dangerous behavior. Secure frameworks can provide automatic escaping, but developers must understand when that protection applies and which features bypass it. The browser ultimately interprets the final output, so defenders must evaluate the exact destination, not merely the original input field. Several related security concepts are often confused with XSS. Structured query language, SQL injection, changes the meaning of a database command, while XSS changes what the browser interprets and executes in a web page. Cross-site request forgery, CSRF, tricks a browser into sending an unwanted request using an existing session, but it does not require injected script to run inside the trusted page. XSS can sometimes enable actions that resemble CSRF because the malicious script already operates within the application's origin and can use the page's normal functions. Secure web connections also do not prevent XSS. Encryption protects data while it travels between the browser and server, but it faithfully delivers vulnerable content along with legitimate content. These distinctions matter because each weakness calls for different primary controls, even though a single application may be exposed to more than one of them at the same time. Before we continue, this is a brief promotional message. This episode is brought to you by the Bare Metal Cyber Academy. The Academy provides a place for people who want to continue developing practical cybersecurity knowledge through clear, structured education that supports careful reasoning and real defensive decisions. You can visit baremetalcyber.com to explore the Academy and see the learning opportunities currently available. Topics such as secure application behavior become easier to apply when the underlying concepts are explained in direct language and connected to the decisions professionals make. Now, let's return to cross-site scripting and examine why several defenses that sound reasonable can still leave unsafe output paths in place.
Input validation is useful, but it is not a complete XSS defense. Validation checks whether data matches the format, type, length, or range the application expects. That can reject clearly invalid content and reduce unnecessary exposure, yet valid-looking data may still become dangerous when inserted into the wrong output context. Blacklists are especially fragile because browsers accept many forms of markup, encoding, and page construction, and a filter may miss a representation it was not designed to recognize. The stronger approach combines validation with context-aware output encoding and safe page-building methods. Data should remain data throughout the application's processing path. When an application must accept formatted content, sanitization should use a well-maintained method designed for that purpose, rather than improvised string replacement. The security decision should be based on how the browser will interpret the final page, not on whether the original input looked suspicious to a person or matched a short list of blocked characters. Modern application frameworks reduce many XSS risks by escaping values when templates render page content, but automatic protection has boundaries. Developers can disable escaping, insert raw markup, call unsafe browser functions, or combine data and code in ways the framework cannot safely interpret. Browser-side applications also create and update page elements after the initial response, which means secure server output alone may not cover every path. A dangerous sink is any operation that places untrusted data into a location where the browser may interpret it as markup, script, or another active form. Safer alternatives create text nodes, assign plain text properties, or use framework features that preserve the separation between content and code. Security reviews, therefore, need to trace data through both server-side and browser-side logic. Trusting the framework without understanding escape hatches can hide the exact locations where the application stops enforcing that separation. Content Security Policy, CSP, can reduce the impact of XSS by limiting which scripts the browser may execute and where supporting resources may come from. A strong policy can block unexpected inline script, restrict external script sources, and create useful violation reports. CSP is valuable as a defense in-depth measure, but it should not replace safe output handling. Weak policies may allow broad sources, unsafe inline execution, or other exceptions that preserve exploitable paths. Even a carefully designed policy may be weakened by application features that load trusted scripts capable of processing attacker-controlled data in unsafe ways. The most reliable design prevents untrusted content from becoming executable in the first place, then uses CSP to make remaining mistakes harder to exploit. This layered approach recognizes that preventative coding controls and browser-enforced restrictions address different parts of the problem rather than competing as substitutes.
Session protection deserves careful treatment because exaggerated claims can obscure the actual risk. The HTTP-only cookie attribute can prevent PageScript from directly reading a protected session cookie, and the secure attribute limits transmission to encrypted connections. Same-site settings can reduce certain cross-site request behaviors. None of those controls repairs an XSS flaw. Malicious script running within the trusted origin may still issue requests that the browser automatically associates with the user's session, read sensitive page content, change transaction details, or present a deceptive interface. The user's privileges also shape the consequence. Script executed in an administrative page may reach functions that are unavailable in an ordinary account, while script on a public page may have a narrower effect. Risk assessment should therefore consider both the technical execution path and the authority, data, and business actions available through the affected page.
Detection requires more than searching logs for obvious script tags. Useful evidence may appear in web application firewall events, application error records, unusual request parameters, reports from CSP, browser telemetry, security testing results, or complaints about altered pages and unexpected redirects. Stored XSS also requires defenders to identify and remove the malicious content from the underlying data source, not merely patch the rendering code. Otherwise, the corrected application may continue to deliver harmful content through another unsafe path, or the content may execute again if the patch is incomplete. Incident response should consider which pages displayed the content, which users viewed them, what those users could access, and whether the script caused unauthorized actions or data exposure. Evidence must be preserved carefully because browser side effects may be brief, user-specific, and difficult to reconstruct after the page changes or the stored content is deleted. A practical way to evaluate XSS risk is to trace untrusted data from source to destination. Begin by identifying every place data can enter, including form fields, request parameters, stored records, imported content, and values read by browser-side code. Follow that data through transformations and note each location where it is written into a page. For every destination, ask what context the browser will interpret, whether the framework applies the correct encoding automatically, and whether any function deliberately treats the value as markup or executable content. Confirm that rich content is sanitized with an appropriate maintained mechanism and that CSP adds a meaningful second layer. Testing should include both server-rendered and DOM-based paths, along with different user roles and pages that expose sensitive actions. This method turns a broad concern about malicious input into a concrete review of data flow, browser interpretation, and control coverage. Cross-site scripting is the failure to keep untrusted data separate from executable browser content. It succeeds when an application places attacker-controlled material into a page or page update, and the browser runs that material with the affected site's origin and the victim's available context. The result may include exposed page data, altered content, misleading redirects, unauthorized requests, or actions performed through an active session. The correct defense is not one filter or one browser setting. Applications need context-aware output encoding, carefully limited sanitization where formatted content is required, safe framework and browser interfaces, strong session protections, and a well-designed content security policy as defense in depth. The practical decision is to inspect every path where untrusted data reaches the browser. and verify that the destination treats it only as the kind of data the application intended. That is how defenders stop content from crossing the boundary into code.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.